Thank you for the presentation. Questions to the cell controller project? Maybe I have one. So afterwards I comment on the academic definitions actually. First, it is really exciting to see how you were able to operate their distribution cell as an island. What about scalability actually? So with regard to transferring the concept not just to the pilot, I think it was actually a couple of years ago when it was.
That's true. Yeah, I mean, I haven't seen similar things in the past, partly maybe. So I think it's still very up to date. But scalability was one of the major parts which are included in the cell controller. So the customer here, Energienet, so it's the transmission system operator, put it into the targets to have scalability, to be able to, in this concept, to be able to integrate electric vehicles, to be integrated, to integrate photovoltaics. So this was one of the big things which were asked for. With regard to it's been a few years ago and what has happened since then. Originally the plan was basically to roll it out for all over Denmark. However, this kind of technology, like implementing everywhere ICT, maybe upgrading partly, it was very, very expensive. And that was the main reason. And of course, we haven't had any blackouts since 10 years or so, for 10 years. So that didn't really help for pushing this concept further. And therefore, currently there are some further following up projects where it's kind of a cell controller light being tested. So, but it's not in the premier focus anymore because of, especially of price. But who will pay for that, basically? Yeah.
Further questions? So maybe another one from my side. So you said it's. I saw the comment. It's pure software. So actually, to operate as an island, are there also necessities for any hardware modifications?
Yeah, the original approach was not to add any hardware like storage, basically. I mean, that was the idea, but make use of what is implemented there. However, if you then go into the system, into as we did the modeling, we needed to get parameters. So we went there actually, we had a view at that and collected data. And most of the CHPs, also the wind turbines, they were pretty old, basically. So they were not meant to be able to operate in island mode in terms of speed control or voltage control. Voltage control AVRs, they were quite good, but typically the speed control, the frequency control had to be added. Besides, of course, the communication structure and SCADA system yeah.
Thank you. So maybe just an additional comment in that direction. So I think this is a typical idea of a microgrid actually. So if we are now again with definition, so I bring my academic hat on that here. So microgrids is actually a distribution grid that is operable as an island and connected to the grid. And so this is the case, even if it's not a small one, but a larger one. So,
yeah, that's why I have my difficulties with micro.
I just add on that, and especially so you introduced also the new term of cell controller. This is also since years a typical concept. So cell is actually nothing more than that it's a grid area that is controlled by a controller specifically. And so if it adds island functionality and grid connected functionality, you can call it microgrid. And so this is actually an important topic, and it's also a very interesting activity going on in Germany at the moment. So we are running very large projects on grid restoration, so I'm heading also working groups on that and an IEEE level. So as soon as you have distributed generation at site in the distribution grid, it would somehow be very strange if even the sun is shining and you have PV, that you have a complete blackout. So this is something part of digitalization. Of course, it's not unintended islanding, but it's an intended islanding, and so it needs to be part of a digitalization concept and needs to be implemented. So it's really fascinating, and so we are running with a couple of distribution system operators in Germany already case studies on that, and so there are already some grid operators that can operate as an island, and including renewable energies here is quite an interesting topic. Okay, so I'd like to open up now the panel discussion. So we have approximately 10 minutes before lunch. So if you like to go into further discussions or addressing further questions to the panelists.
Good afternoon. I'm Kaushik from Tata Power. So my question is that, in Indian context, the microgrid primarily is for those locations where, the grid power is not there. And the provision of interlinking when the peripheral electrification and grid will come, but the major challenge is coming in terms of the cost, due to the high cost of storage and if the DG is there, so the running cost. So is there any major progress in this direction to make the microgrid financially viable? Because in India, the tariff is totally political, so even they are not ready to pay 2-3 rupees per unit. And at present, we have done microgrid projects in Bihar. The actual cost is coming in the range of 20 rupees per unit. So how the scalability can be done, beyond pilot?
Maybe to comment from my side, so I think this is really an important question, and I think there is a huge number of people in India that are not in the interconnected system, so where we need to. So I think this is coming a bit short in this conference actually, because with the number of people not having interconnected systems, actually they are much more affected than we see in that conference, but. I think, as you pointed out, well, it's costing something, and it's a political decision if it's a kind of a business model also for investors in this direction, and how much it's worth investing in that area. And so what we see worldwide, so it's a new business field. Microgrids are installed, so it's mainly combining diesel units with fuel-saving mode with PV, because this is seen to be very attractive. And of course, in certain areas, diesel systems are not so attractive anymore, and also diesel prices are increasing. And so there, of course, battery storage is coming into play. But it's a really tough question, and I think this, I would be very interested in seeing some large-scale studies on how to bring that, how to make electricity to all, actually. So this, I think, is still a challenge, and to understand how to do it and how to bridge also ways maybe into future interconnected systems, and maybe being compatible on that. Any further comments on that from the panel? Okay, further questions, comments, discussions? So I was, maybe I will organize that. So for the, so we have seen now several elements of smart grid technology. So we have seen from in using battery systems in the distribution area for different purposes. So we need measurement information, we need control equipment. So this is smart grid technology. We have seen virtual power plants, you controlling a portfolio of generation storage load units actually. We have seen from Siemens' presentation of some active network controller with state estimation and different use cases as well. And the cell controller project from Denmark. So these are all solutions based on digitalization, and so this is, I think, so this is the basis of any smart grid concept. And to be very clear, also maybe sharing some experience from Germany. So this kind of controllability is not yet existing really on a distribution level in Germany. Even having such high amounts of renewable energies in the system, this has not happened with this digitalization concept. So there still the question is on the business model, and I think this is still an international question on how much ICT do you really need in the system, when do you need it in the system. I think it will come. So I just presented yesterday, it's a mega trend going to digitalization, but the question is when to enter and for what purposes actually. And often we have certain solutions which have more pilot character. So we have seen part of them also already here in this session. So it looks interesting, but the scalability in the business case is not yet available. And so this is a big question, and I think this is also part of developing kind of a roadmap for those who are thinking of doing that also now in the Indian context, to have a good understanding of what do you need when to gain the objectives reached. And don't start too much with the very fancy international things that are under discussion. I think it's important to run pilot projects to get an understanding of the technology, but this is the next level of doing it more cost efficiently, and a certain degree is necessary. So that is a very interesting point to understand how much and where and when it's really going to happen. This is a difficult question. Even Germany, we have not yet gotten a very good answer to that actually, and it's still under discussion. But you see that there is a huge potential and many possibilities, and there has been many things tested already. Okay, so any further question, feedback, discussion? I think everybody, over there, yeah, please.
Good afternoon, sir. It is indeed an interesting session, and since the question came up about the Indian scenario, I just had a general question to the panel. What do you think would be better, decentralization of power generation or actually bringing the entire country into the grid system? Or would you say that having microgrids at places where we don't have grid-connected villages, just keeping it that way and have, microgrids and decentralization of power generation? Or rather, you would suggest that it would be better if the entire country is connected to a single grid, which is more viable, or which is a better solution for it?
Well, I think that has to be calculated. So I think there are, throughout the world, we have, and also in India, we have areas where it's quite costly to get a grid extension of transmission system there. And so it's, from my point of view, not the final solution. Also building the lines and bringing the technology there, it's taking time. And so my experience is that doing decentral ways, and this is why it's also a mega trend, it's just much faster because it's modular technology. You can just go there, implement a hybrid system, so it's available on the market. If you now start planning transmission and interconnection and so on, it will take many, many years, and it's maybe not even as cost efficient as if you do it just decentral. But of course, it's a big gray area. So there, I think in certain areas, it's quite clear how it should look like. And there is a gray area in between where you need to assess, does it make sense to go into a grid extension to go there and electrify, or do you start from building islands, let's say, or maybe even a modular concept where you say, well, I start decentral and then I plan that it's interconnected and extended in that way. So I think this is a country roadmap which is really necessary for an Indian context. I would be very interested in seeing that and maybe also supporting and discussing that, because it's extremely important. So I personally think it's a big challenge to realize electricity to all. It's a really big challenge, and this can be organized, it can be strategically planned. I know that India has been done a lot of effort in that area as well. So it's a big challenge, and there's not an easy answer to that. Additional discussion? Yeah, please. This is a blackout micro, it's always going.
Anup Singh from IIT Kanpur. Since you just raised this issue in response to the question about mini-grids as a solution of energy access to the millions of people in the rural areas, I have been looking at this issue over the last probably about 7-8 years. And I used to be on the other side of the edge and initially really actually trying to say, okay, mini-grid seems to be a solution. Because they don't have anything, so why not let's give them 4 hours of supply a day. But then I was convinced otherwise by myself later on. I says, is it only us who have the right of 24-hour supply? They will always, for the next 10-15 years, continue to survive on a 4-hour or 5-hour supply. They have equal right to see all those, stupid serials on the TV also. So I think then the next question came, and this is an area where we have been working also, is what happens to the mini grids once the actual grid has arrived? And there actually the incentives are completely in different directions. The mini grid would never want the distribution grid to reach there, because it will, especially those which are based on private investment, because they will lose their money. And public investment-based mini grids are most likely to fail, and actually they tend to fail. So the intermediate solution was being suggested, and it has been implemented in the state where I belong, is there is a middle solution that once the grid reaches there, how do you subsume it, under what conditions? And to some extent it can help, but in any case, because many states have now signed an agreement with the central government, which is called Power for All program. So every state is in an aggressive mode to extend. So as of now, for the timing, maybe we'll see mini-grids losing their growth potential, unless concerted efforts are made across the states where the new solutions that to extend the life of mini-grids can also be really implemented. Thanks.
Thanks a lot for this comment. Any further contributions in this direction? So we were now drifting to the mini-grid topic, even talking about smart grid and virtual power plant. But I think it's important, and it should get room in this conference as well. Okay, so if there is not any more contribution, I think we are just in time to finish the session and go for lunch. So I thank all the presenters for their really high quality presentations and really worthwhile contributions, and also for the discussions on that really relevant topic. So enjoy lunch. Thank you.